Progress.
All right, as for today, we are going to see if we can wrap up chapter 6 here. But what we are going to do is now look at problems generally and identify the factoring strategy, because the instructions for problems, they usually don't say factor by grouping like that. It has a single instruction. It says factor completely. You want to break it down, all right, to its base components, all right, in their entirety. So, all right, all these pieces that we talked about, greatest common factor, all right, pull it on out. All right, then count the number of terms, okay? 2 terms, all right, that's either a difference of squares, which is essentially diamond still. But the one thing you want to watch out for is the sum and difference of cubes, right? Not one's wash the bunny face. All right, so we got our strategy. All right, so 2 terms. All right, 3 terms, that is always diamond, whether it's the simplified diamond or the full diamond. 4 terms, we have our 2 methods of factor by grouping. 2 by 2 grouping, that's our common one, right? And remember that the tough one, that 3 by 1 grouping, all right, which is basically a 3-term long difference of squares. But always when you have 4 terms, start with 2 by 2 grouping. If that doesn't work, then try 3 by 1 grouping. And if none of these terms, all right, if you can't break it down, okay, for example, something like a squared plus b squared, when you cannot factor it, all right, we call that what? Prime, okay? Make sure before you call something prime, you have really tried to break it down. The temptation is, all right, everyone's like, they tried one thing, didn't work, maybe they messed up, maybe they didn't try enough things, and they're like, oh, it's prime. Most things are not prime. The reason prime has, right, that name is that it's special, all right? Most numbers are composite. Most polynomials are composite, okay? Yes, prime things exist, okay? That is the absolute last resort. All right, and then of course, in order to check it, box them back together, multiply back together. So let's test out, all right, some polynomials and see how we can break them down. All right, so start with this guy. What should we do first and foremost? Say one more time. Greatest common factor, right? Let's pull the 5 out. So greatest common factor, always the first step. All right, I pull the 5 out, all right, 80, and when I pull 5 out of 80, it becomes 16. Then we count the number of terms. I have 2 terms, okay? It is not a sum, okay? Sum is the prime option, so it is definitely not that. Then I need to identify, is this a difference of squares, a difference of things being squared, or a difference of cubes, right? Difference means subtraction. Okay, so this is clearly a difference. All right, so are these squares or cubes?
Squares.
Squares, how do you know?
T squared is T.
Yeah, t squared, but looking at the number is an easy one too, right? I was like, oh, 8 times 8, that's an easy one, right? What cubed makes 16?
2. No, wait.
2 cubed is 8.
Oh, right.
So AKA nothing, right? No integer at least. So usually looking at the number, right? And don't forget, we have our calculators, I can check it, all right? Cube root. All right, 2.5198421 cubed makes 16, all right? Hence nothing. So don't forget, that's what your calculator is for. So, all right, I can identify this as something squared times something squared. Difference of squares, the best thing is when you identify one is a positive, one is a negative, right? We already identified the 16. What times what makes 16? That's the same. All right, then what times what makes t to the fourth? T squared. I can also do that via diamond, right? With that one, I can do the diamond and zeros on the bottom, but these, the difference of squares is one that we can kind of do just piece at a time. Then, remember the instructions, factor completely. Knowing when to stop and when to keep going is important. This guy right here, that is now a sum of squares. This is our prime example up here. So that one is done. What about this?
Difference of squares.
That's another difference of squares. I can actually break that down again. What times what makes 4? What times what makes t squared? T. Now I have that completely factored. Now every piece, right? The whole idea is every piece within something that has been factored is prime. It cannot be broken down any further. 5 is prime, all right? A sum of squares is prime. A simple, all right, this is a simple polynomial, all right? That is prime, that is prime. I cannot factor those any further. That one is tricky because there's actually an additional step. A lot of times people get to that step and they're like, oh, I'm done. Don't forget, keep looking. Look at each piece, one piece at a time. Can I break 5 down any further, or et cetera? All right, let's see if we can break this down. So first thing, greatest common factor. Can we pull anything out? No. All right. Which means now we have 4 terms. What approach should we use?
2 by 2.
2 by 2. Factor by grouping. When you look at it just 2 terms at a time, now of the first 2 terms, what's the greatest common factor?
2x squared.
2x squared. When I pull 2x squared out of 2x cubed, what remains?
X plus 5.
Oh, yes, the whole thing. Yes, what remains is x plus 5. What about the second 2 terms? What do I need to pull out?
Can.
1, super important, all right? That we pull out 1 as our placeholder, and notice, right, I'm writing it as the placeholder. When I pull that all the way out, I pull x plus 5 completely out. When I pull x plus 5 completely out, all I have to do is cover up those x plus 5s, and what remains?
Squared plus 1.
2x squared. That's why I have the plus 1 placeholder. Remember, you can always factor a 1. If I wanted, I could write the greatest common factor is a 1. All right, just doesn't help us at all. But here, all right, that does help us. Once I'm even at this step, I want to double check and make sure I can't factor these any further. All right. Once you have something as a first degree, all right, that one's definitely done. All right, so that's prime. All right. This, right, there's no squares in here. This is also, if at best, a sum of squares. So, all right, this is prime as well. All right, what do we do first?
Take out X cubed.
Take out what?
X cubed.
X cubed, greatest common factor. What? What's up, Fred?
I was just looking where you were at. I missed a step.
This is a different problem now.
Not on here.
Right here.
Oh, okay. I got it covered up with your writing.
Oh, okay.
Thank you.
And then, all right, once you have the greatest common factor, again, we're always focusing on whatever is remaining inside the parentheses. What is inside the parentheses here?
Read. X squared minus 2x. Yeah. Like a
35. What do we, oh, 3 terms, that's what you guys are saying. Yes, 3 terms. All right, what do we call this, right? When it's got an x squared and 3 terms? Quadratic, right, is called a quadratic. The only way you can perform the diamond, all right, is on a quadratic. Okay, so even though, right, we talk about 3 terms, this only applies to quadratics. If I have an x cubed, if that same thing said x cubed minus 2x minus 35, I could not do it. So only quadratics, all right, that is the important part there. Factor by grouping, you can do that with whatever powers you have, all right? But 3 terms, the diamond only works on quadratics. X squared has to be the highest power. All right, so once we have that, our wonderful diamond that we love. A times C goes in the top, all right? And remember that that's the multiply term. Down here, the B term, that is the sum term. So what 2 numbers multiply to negative 35 and sum to negative 2?
7 plus 5.
7 and 5. And which was negative? I missed it.
7.
All right, negative 7, positive 5, right? Negative 7 plus 5 makes negative 2. Negative 7 times 5 makes negative 35. All right, always double check. It is the quickest check, all right, that you can do, because those values sum to the bottom, all right, they multiply to the top. The diamond always works as long as you double check it, because I see people write stuff in the diamond, then they keep going, all right, but the diamond didn't actually work. So make sure it satisfies the values within. This is the special case, right? Remember, when A equals 1, I can jump straight to the factors. This is my favorite type of diamond because this is just super fast. Once you identify the factors, those are, all right, the pieces, all right, of the polynomial.
X plus 5. I caught it from that swing.
All right, so. Two A cubed plus 12A squared plus 18A minus 8AB squared. Brian, what do we do first?
Find the greatest common factor,
Which is,
2.
is that it?
2 and 4, I believe.
I don't think 4, because that first term only has a 2, so 2 is, 2 sounds right, but I don't think that's everything.
2.
Anything else in all of them?
Not trying to think of.
What about the letters?
Okay.
A. All right, how many terms do we have, Brittany?
3 times, 1, 4.
Which means what approach should we use?
The quad. The group being.
Grouping. All right, 2 by 2 or 3 by 1?
2 by 2.
Always start with 2 by 2, right? That's literally why it's ordered that way, right? 2 by 2 is first. If that doesn't work, then we'll try 3 by 1. But basically, always just count your terms. I have 4 terms. Let's do grouping. Let's see what we got. And A comes out of the first 2 terms. 1 comes out of the second 2 terms. Ah, they don't match.
Yeah,
Okay.
So that is the first thing we have to identify. They don't match. That's a big problem, right? We saw above, right? Oh, X plus 5, they matched. Excellent. So when they don't match, does anyone remember? Yeah, we have to back up. All right, and try 3 by 1 grouping. So the important part is that means this whole piece, right? That didn't work. All right, that was nothing. Now we need to do 3 by 1 grouping. 3 by 1 says do the diamond on the first 3 terms because it's 3 terms. 9 and 6. 3 and 3. That means that's A plus 3 times A plus 3. Also, I could rewrite that as A plus 3 squared. And that's the point of the 3 by 1 grouping, to get something quantity squared. I need to do the same thing, right, on the back end piece here. Basically, I need to identify it is something squared, right, that makes 4b squared. So what squared makes 4b squared?
2B.
2b. Well done. Once you have it written like this, that that is a difference of squares, which means it's just a big difference of squares, but one has a positive, one has a negative. We identify our terms as the first term and the second term. The first term just happens to have two pieces. So what's the first term? A plus 3. And that goes into both of them. What's the second term? 2b. Drag down, with 2a. Our 2a comes with us. And that's the toughest one without a doubt. All right. But you should always be able to recognize this because you had 4 terms, 2 by 2 grouping didn't work. Then we have to do 3 by 1 grouping. It's the toughest one because this is a diamond within a difference of squares, and that's the tricky part. We did a difference of squares as the last step, but we did a diamond within it. So that's what kind of makes that challenging. All right, for this guy, before I write another step, what do we need to do first? And it's a biggie. Greatest common factor, all right? And it's a big one, all right? So what's the number part of the greatest common factor?
3.
3. All right, we pull that value out, right? Always just do it one piece at a time. Then what about the x's? X squared, right? Notice, right, we're always pulling the lowest power. Why can I not pull an x cubed out?
Because there's an x squared.
Right, because x squared, that is the highest power. It's actually in there twice, right? That is the highest power that I can pull out. I can't pull an x cubed out of an x squared, all right? 3 is the highest number, right? So you always just look at what the lowest number is. Greatest common factors, it is the most important step because can you keep doing factor by grouping and diamond and all that without doing greatest common factor first? Absolutely. But your numbers just become huge. All right. It all still works. All right. It's just, it takes you 3 times as long if you don't get the greatest common factor out first. All right. And then the y.
Wait to the 4th.
Y to the 4th. All right. So what do we got left? Let's see. 2. That's it.
That's great.
All right. Then what do we do?
Light the paper on fire.
Diamond's gonna work?
Oh, let's see if we can do diamond.
Wait. We have to put them in descending order.
Ah, excellent, excellent point. Let's do descending order and then let's see if we can do diamond. So what multiplies to 2 and sums to -7? Nothing? You sure? What are the only things that multiply to 2?
1 and 2.
1 and 2, since it's a negative on the bottom and positive on the top, that means they have to be negative, right?
But it's still -3.
Oh! So Anya, yes, as you said initially. What's the matter? Diamond doesn't work, all right? I want to show this because, all right, the diamond doesn't always work, but this is how you recognize it, right? You basically check your values, all right? The diamond did not work. Also, be aware, the diamond also, I knew that this wouldn't work before I got to the diamond because in order for there to be an X here, there has to be an X squared right here. Okay? Because there's no 2 factors that can create a single X without there being an X anywhere else. Just so you're aware of that. All right? So that means this, all right, is as far as we can go, and be aware, this actually is in descending order in terms of X. Because there is no X, there's a single X, and there's Y squared. It is descending in X's, ascending in Y's. So it's perfectly fine to leave it in that form. This form is fine as well, Brad.
Where did you get the -7x1?
When I factored, right, 3 out of -21 becomes -7. I pulled x squared out of x cubed, gives an x. And I pulled y to the fourth out of y to the fifth, which leaves a y. So just doing greatest common factor is how I got to that next step. And that is as far as we can go. But that's what I was saying. Always check to see if you can go any further, all right? All this factoring is about knowing when to stop and when to keep going. Okay, all right, right here. What are we looking at right here? Greatest common factor?
Yes.
One or none, yes.
Yeah, sum of cubes.
Oh, sum of cubes, usually pretty obvious. How'd you know it was cubes?
X times the cube.
It's powers of three, all right? Yes, again, it seems obvious, but all of a sudden people are trying to pull it apart into squares and stuff. Remember, by definition, it is called cubes because it's powers of three, all right? Also, all right, what number cubed creates 125? 5, all right? So in order to identify this as cubes, let's go ahead and write it in terms of cubes. All right, so that means what cubed makes 125x cubed?
5x.
5x. What cubed makes y cubed?
5.
Y. All right, so you want to break it down to its fundamental parts just so you identify the pieces, all right, that create the cubes. Then we get to do my favorite part of the dance, the best dance step that there is. Remember what it is? Watch the bunny face. All right.
You weren't here for that.
Oh my gosh, Hannah wasn't here? Oh, you're right. And we should completely do the dance, everyone. All right, you guys can chair dance it. Hannah, you have to stand.
I have to.
I was like, and anyone you can convince to stand with you, I'll stand.
Anna, you brought it up. Did you brought up?
My feet hurt.
All right, so, all right, do the bunny. Everyone appropriately chair dance or everyone stands. Okay. All right, and then, all right, do the bunny. Watch the bunny face. All right. Yeah, I didn't want to deprive you of that special moment that we all had.
I can't wait to watch that in the lecture video. Oh,
We
it's
got
gold.
entertainments
It's
and
gonna be golden.
High on life, man. This is math. Can't get any more fun than this. All right. Okay, so remember that once you identify those terms, 5x and y, all right? And actually, let's fill in the signs now just to, you can do that at the end. Remember, we use SOAP, same. All right, it's positive there. Opposite, always positive. Same, opposite, always positive. All right, that's what SOAP stands for. That's the wash the bunny face part. All right, and then we create the bunny. 5x times 5x. 25x squared. 5x times y.
5xy.
That one's always usually the easiest one. 5xy, and then
Y squared.
y times y, which you are absolutely correct, y squared. And that is washing, and notice that that kind of looks like a bunny. So there's soap on the bunny, wash the bunny face.
Put teeth on it, it works.
I was like the.
There you go.
Kind of like a tongue.
Now I got it.
It's fine.
I did that last time. It made it make sense.
Does that make it better?
Yeah, lots. Way better.
When do you know when to use soap? Is it always on some of cubes?
Only on the bunny, cubes.
So same.
Same, opposite, always positive.
It always calls.
Yep. Same, positive, opposite, positive, now negative, always positive. So that last sign is always a plus,
Wait,
right?
do that again, the same way?
So this one was plus, right? Same, plus and plus, opposite, positive, now negative, always positive.
Here we go.
So, yeah. And if this was negative, that would be negative, and then that would be positive, and that would still be positive.
And this is only when they're.
Cubes. That's why this dance move, you use soap on the bunny. It is only for cubes. All right, but that's why it is a super specialized dance move because we don't factor cubes a lot. We do the diamond way more than cubes. But this dance move, that's why it's so special, because it doesn't come up a lot, right? But it's very specified. I've got to get going.
What's the dance?
No, no, no,
No,
no, no, no. No.
Again?
Stop it.
No.
Did you just ask? The dance move is watch the bunny.
No,
different
diamond
one.
one. Jeez.
Oh, different dance moves.
Yes.
Totally square.
Yes, my attention span is not there.
Square, not too worried, 16. Okay. All right. Greatest common factor.
Where'd it go? What is it? Yeah. All right. Happy Halloween.
Take care.
Happy Halloween.
One weekend.
And then what do we do?
Quadratic.
It is quadratic. And the dance move is the diamond. Do the diamond. All right.
I don't think I remember the diamond dance.
Okay. The diamond is just one move. Right? The diamond is just this move.
Oh, yeah, but it's not a dance.
Oh, dance move.
Yeah.
All of this together, all the dance moves that we have create the polynomial dance. All right, so yes, when I say dance, I'm specifically usually talking to a dance move within the grand form of, yes, at right before the final, we'll do the whole polynomial.
Outstanding.
All right, every single move. All right. In order, this is full diamond, right? What goes in the top?
-12.
-12.
AC, so A times
Oh, yeah.
This is the full diamond. We technically always put AC in the top, but a lot of times the A is 1.
Mhm.
All right, what goes in the bottom? -1. Remember, also the important thing, remember the diamond only has numbers, no variables in it. All right, so what multiplies to -12 and sums to -1?
and -3 and. No, it's -4 and 3.
Yeah, literally what you created to make AC was the same thing. So that happens sometimes. It means I don't have to list my factors. I literally have it right there. It's 3 and -4. All right, but remember, okay, with this one, all right, I'm gonna drop the 4 temporarily. 3a squared and -4, those drop down. I cannot jump to the factors here, but I rewrite the middle term.
Yeah.
With the factors. So that means -4 and +3. And then what do I attach onto them? Thought I heard it. What? The variable. What variable? A, in this case. And then now I have 4 terms. What do we get to do?
2 by 2.
Group. And specifically 2 by 2 grouping, yes.
Equals 3A.
With the diamond, all right, the AC method always works. And just like we saw above grouping, these 2 terms will always match, okay? And it doesn't matter if you mess that up. The biggest thing, all right, and I do that slowly, bringing that variable down, mostly because remember we saw when it was AB, or when this variable gets complicated, make sure you look back and bring and attach whatever that variable is. This diamond will always work out.
Always do the -1. For the 2 by 2.
The -1.
Or the +1 for a placeholder.
Or
No, just actually just two examples. It didn't, it just happened in both cases we've looked at today, right? But definitely that is not required at all. I was like, pure coincidence. We looked at plenty last time that didn't have that. Yeah, just the two examples we've looked at today.
How do we know when to use AC instead of like the multiply and sum? Like the fourth problem we didn't do AC.
Excellent, because this one. A is 1.
Okay, so it's only if there's a number in front of that, like.
If there's a number in front of this, the squared term, you cannot jump to the factors. That's why I was saying, this is simplified diamond,
Okay,
all right? When A equals 1, I can jump straight from the factors, boom, to the polynomial, all right? If there is a non-1 term in front of that, then you have to do the complete diamond.
okay.
All right, we end up with our terms. And again, remember, we can always check by boxing it back together. All right, one last one, x squared plus 9. Greatest common factor? 1, none, yeah, however you want to say it. All right, and then we have two terms, and what do?
Squared or sum?
Sum of squares, right? So I should be able to pull it apart just like that. One of them's negative.
Would be x plus 3, x minus 3.
A positive times a negative becomes a negative, right? So one can't be positive, one can't be negative. What? Does that look good? No?
You have x plus 3 squared.
What?
You could do x plus 3 squared.
Oh, could I rewrite it as this? Okay, that is the same thing. Yeah, be aware, we only do that in that one, in 3 by 1, because what we have to do. But these are the same, and never hurts to know that. Let's just check to make sure.
The first one went okay.
Yes, this is fine, this is fine. Let's just check to make sure that that looks good.
Yeah.
When we box this back together, x times x becomes. 3 times x becomes. 3 times x becomes. 3 times 3 becomes. So when I write this out. Is x squared plus 6x plus 9 equivalent to x squared plus 9? No. All right. This is the temptation. All right. When you jump to the factors, you're like, that seems like it makes sense. This is why we do the check. This is also the warning that I gave you initially. All right. Sum of squares is prime. Do not try and factor a sum of squares. Okay. And I give the warning explicitly, all right, and we do one right at the end because it's just so tempting, and it's because we have our sum of cubes, our difference of cubes, and our difference of squares, and we're like so good at pulling those apart that you try and pull apart everything. Do the check. I know I'm bad at it, all right, but it's also because I was like, I'm pretty good at factoring. Okay, I know all the rules. You guys should check yourselves. Okay. That means this is prime.
And that means don't even do all that.
I can't. No, it definitely does not factor, right? This is not equivalent to this. This is equivalent to this, which is definitely not equal to that.
Done. prime.
Yes, which also, all right, careful not to pull apart things that can't pull apart, but be careful to say prime too early. Way too often, there was what, how many primes did we just do? 8? People are like, if 7 of those
Right.
you listed as prime, you made a mistake, right? People are like, oh, you know what's fast? Prime, 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 prime. Oh, I can see a greatest common factor. Prime, 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 prime.
But we weren't wrong at the x plus 3, or the x plus 3 squared.
Okay. We definitely were wrong right here. This is not equivalent to this. That does not pull apart.
Oh, so then this one is, okay, never mind. I was like, we didn't.
All right.
Are these two equivalent? Yes.
Yeah. That's what I was getting at, yeah.
Is x plus 3 times x plus 3 equivalent to x plus 3 squared?
But it
Yes.
doesn't work to that.
But it is definitely not equivalent to this because this is actually equivalent
All right.
to x squared plus 6x plus 9.
Okay, I bet y'all wasn't the only one saying that.
Yeah. To write out x squared plus 9 is not equal to x plus 3 times x plus 3. But that is equal to x squared plus 6x plus 9. That's the finishing statement, right?
What a catchy deal there.
And it's because the simple check, right? When you do the simple check and you box it, I can see that that becomes that. That is definitely not what I started with. All right. With everything, all right, the factoring is the lead-in technique to solving problems, right? We're all about solving problems, and this brings up the big concept of we've been solving linear equations where every time you try and isolate x. When you have a quadratic or higher power function, you cannot just try and solve it for x squared or x. You'll never be able to isolate them, not without factoring. We do all that factoring so you can actually solve the problems. What's known as the zero product property? When you have something factored, what that means is the equivalent of multiplying it or dividing it by that term, and 0 divided by anything is 0. So the idea here is that I divide the left side by x minus 3, then I divide the right side by x minus 3. That leaves me with x minus 2 equals 0, and I can solve that really, really easily. Add 2, add 2, x equals 2. However, why did I pick x minus 3? There was no reason to do that, so I can do the same thing and divide both sides by x minus 2. That leaves me x minus 3 equals 0. Then add 3, x equals 3, meaning the solutions are both 2 and 3. The zero product property says when you get something factored, you can then solve the individual equations. Right now, you don't have to do that step every time. The idea is that from your initial equation, essentially you say this breaks into 2 equations, x minus 3 equals 0 and x minus 2 equals 0. And then you solve those individually. This is the benefit of factoring. I have a 1-degree polynomial that I can solve equivalent, right? And another degree to solve. Now beware, this only works if this is equivalent to 0. If there is any non-zero number over there, you have to get it to 0 first. But the whole idea is that we factor this down and then you can solve these equations. Let's look at ones that are slightly more complicated. So, all right, temptation, like I said, everyone wants to solve it. When you have a quadratic or higher, all right, factor first. That's why we spent all this time going through all those factoring techniques. Because in order to actually solve this equation, I have to factor this. So ignore the equals 0. How do I factor x squared plus 7x? What do I do, Brittany?
Wait.
How do I factor this?
With the like, with the most common.
Greatest common factor. What's the greatest common factor there? X. So pull an X out. That leaves x plus 7 equals 0. So again, it's simply just factoring. Now I have exactly the form we just had. This breaks into two equations. X equals 0, x plus 7 equals 0. As soon as you have it factored, all right, and that means things being multiplied. Because again, if when a 0 over there, the 0 prior property, if I divide that, I end up with this equation. I divide this, I end up with that equation. That's the concept of this property. 0 is a special number and super helpful to us. Be aware, only when things are being multiplied. The temptation is I see people are like, oh, x squared equals 0, 7x equals 0. Doesn't work across addition. This is multiplication. And then, so hence, x equals 0 and -7. And that's the solution. Easy peasy. All right, similarly, x squared minus 8x equals -16. This is exactly what I was talking about. This only works when it's equal to what number? 0. So I need to get this equal to 0. Luckily, there's pretty easy algebra. I'm going to add 16 to both sides. Once you have it equal to 0, then I can start thinking about breaking this down. How do I factor this? So again, ignoring the equals 0. Diamond. All right, it is 3 terms, no greatest common factor. What multiplies the 16 and sums to -8? -4 and -4. And then Kaylin, what's special about this one?
They're the same.
That is absolutely true. Back to the quadratic. What's special about the quadratic?
There is no number in front of x squared.
This is a 1, absolutely, which means I can jump to the factors. All right, I don't have to do the full diamond here, which means x minus 4 equals 0. All right, so it's just factoring, all right, on the left side, but I still have that equals 0. And then I have x minus 4 equals 0. X minus 4 equals 0. Just happens to be the same solution. X equals 4. And basically this works with every single factoring technique we just did. If you can get it into things that are factored, you can then set each piece of the multiplier equal to 0. All right, this can expand to everything we just did. We okay with that? Just factoring, now with some equalities. But 0 is the important number. Some terminology that you'll see throughout Pearson and stuff is the term roots. All right, when we think of roots, what do you think of?
Square root.
Oh, what, the math version, excellent.
Trees.
Plants, usually. I love it that we immediately went to math. All right, it's like, we're actually, the plant version is roots, specifically, all right, where it's crossing from above ground to underground. All right, a root refers to x-intercepts. So when you see that term, that means x-intercepts. When we do x-intercepts, remember how we solved it? That means let y equal 0 and solve it for x. No quick cover-up method here. Basically, all right, we are solving that whole equation equal to 0. What I want to continue to emphasize is that equal to 0 doesn't matter until the very last step. Otherwise, all I care about with this is to do what with it? What have we been doing this whole chapter? Factor, all right? I'm going to factor this. That's all that matters. So no number I can pull out, which means greatest common factor is x to the 4th. All right, and for the moment, I'm gonna drop the equality equal to 0 too, because it doesn't matter. And then what do? That we love? Diamond. Diamond, notice, we're doing the diamond a lot. Diamond is a main dance step, just like the box. Okay? Most of the time, we do the diamond. What goes in the top? 60. What goes in the bottom?
-19. Okay, that makes so much.
Yes. 6 times 10.
I'm getting
AC. That's why it's called the AC diamond. A term, C term. What multiplies to 60 and sums to -19? We get fast at this?
4, -15.
-4, -15. Was everyone with her? Are we getting fast at this? All right. No? Anna, if you were working on it, and that brings up Anna, remember we were talking. If you're struggling to figure it out, what do? Just list them. 1 times 60, 2 times 30, 4 times 15. What do we have? 5 times 12? Or no?
3.
Oh, it is 5 times 12. 6 times 10, 7, 8, 9. That's it. Right. Yeah. That is literally all of them. All right. So if you get confused, just fill it in. All right. It's never going to take that long. Six factors is about as much as we're going to get. That's why I started with that one that was like 20. All right. So you could see that even in the biggest number, I can still eventually figure it out. All right. And yes, they are both negative because the bottom is negative, the top is positive. Fill that in. And then we get to do the full diamond here. And then this, the other reason the full diamond is so awesome, okay, so we get to do the full diamond, and then also what other technique do we get to do? Grouping, all right? So the full diamond has all pieces involved within. Ooh, this is a really good one. I can see it already. All right, of the first 2 terms, what do we need to pull out, Brittany?
2.
2, anything else?
An X.
X. What remains inside Fred?
The numeral 10.
What?
Oh,
As in the X, yes,
Yeah.
an X remains.
Yeah.
But before the X.
Three.
3x.
Oh,
Anything else?
and two.
Anything else?
And a negative.
And the negative. Excellent. Bryant, what do I need to pull out of the second two terms?
5 and X.
5x?
No.
Do I pull? 5 sounds correct. Do I pull an x out?
No.
No. Kaylin, what remains inside?
Negative 3x plus 2.
Excellent. Well done. What's the problem, Kaylin?
The starting one starts with a negative and then they're flipped, so they're not.
In order to correct it, what do we do, Anya?
Negative 5.
Negative 5. When I pull a negative 5 out, that flips the sign. All right, that's the trickiest part, which is why the signs are so important, right? You especially, right? Signs, okay? All right, pay attention to the signs everywhere. And I could see it was messed up, right? Positive, negative, negative, positive. All right, that's kind of the hint, all right? When we pull that out, did this work, Hannah? Why? How do you know it worked?
Everything lines up. Right?
Is there anything else more hit you in the face that it worked?
The same.
Thank you, Anna.
Is that me?
Anna.
Pretty enough.
I was like, sorry, I'm used to saying it to you. The inside pieces, 3x minus 2, 3x minus 2, those are the same. Now we can pull that all the way out. Okay, now let's put it all back to, okay, so all this was just factoring. Now what we're actually doing was solving the equation. All right, so back to our equation.
I don't even know which one it is.
Okay, we could rewrite it up, 6x.
Oh, you can have a hold on, or the.
Oh, we're gonna bring that all down. So, all right, this is what we started with. We have factored that with greatest common factor and all kinds of stuff and turned it into this. So, all right, we had our equation that was basically that whole thing equal to 0, factored at greatest common factor and full diamond. All right, we turned it into this. Now we can break this apart into each piece. Now, each of these are being multiplied. So be aware, this actually says x equals 0, x equals 0, x equals 0, x equals 0. 3x minus 2 equals 0, and 2x minus 5 equals 0. This breaks into 6 equations. Now, good news about those first 4. They're all exactly the same. So a lot of times, all right, but it is x to the 4th. That is x times x times x times x. It's all multiplied, okay? So those are all the same, so there's really not much to do on those ones. These are the only ones we have to quote solve, and solve is a strong word with like, there's not much to do there, right? Add 2, divide by 3, add 5, divide by 2. Hence, x equals 0, 2/3, 5/2. But basically, okay, the whole idea is you turn it into a bunch of things being multiplied. As a note, and you can see it, if it is whatever degree it is, what degree is this equation? The top equation.
Oh,
6, right? And be aware, the one below it is degree 6 as well. They can't change degree, we didn't do anything, right? 1 plus 1 plus 4 is still 6 degree. All right, Brad.
How'd you get 2 over 3 and 5 over 2?
add 2, divide by 3.
Oh.
Two-step algebra. The other thing is that that's like the fast math that basically flip the sign, divide by the x.
Okay.
But I could do that slowly, but hopefully we're good at this now, right? Everyone should solve
I was just
hopefully
hopefully
fast. This is a 6th degree, which means there has to be 6 solutions, right? That's why I wrote this out this way. Because it says whatever degree this is, that's how many solutions there are. Does it happen that 4 of the solutions are exactly the same? Yeah. But, all right, we actually found 6 answers. Just happens to be only 3 distinct answers. All right. So just as a note there. All right, I think we will call it there for the day. Alright, you should have everything to do all the activities. We'll finish this up next time as well as begin chapter 7. Okay, so be aware.